Hello students, now we are going to see an important question, that is we have to convert basically gravitational constant, and it is given in SI unit, that is capital G. It is denoted as given by capital G, gravitational constant, which is given to you as 6.67 into 10 to the power minus 11, and you can see that it is given in Newton meter square per kg square, and we have to convert basically this SI unit system because it's an MK system, so we have to convert this into a CGS system, right? So first of all, I'll ask you the formula for the force, and the formula for the force by Newton's is given as G m1 m2 by r square, right? So if I ask you the unit of gravitational constant, so that is basically Newton meter square per kg square, right? But if I ask you the dimensions of G, right? If you want to find the dimensions of gravitational constant, so we'll have force dimension is what? Mass into acceleration, so that is going to be mLT minus 2, right? And the dimension of r square is going to be your what? L square, and whole divided by what? M square. So basically this is going to be the dimension of gravitational constant. So once we solve this further, so we'll have m minus 1 L cube and T minus 2, right? So that's the basically your dimensions of gravitational constant. Now this will be used basically to convert this SI unit into a CGS system of unit. That means we have to convert MK system of unit into a CGS system of unit, right? So we'll quickly move further, but make sure that you know the dimensions of gravitational constant, that is your m minus 1 L cube T minus of 2, right? So we'll move further. So let's see, we have a system of unit formula, that is N1 U1 is equals to what? N2 U2, where N1 and N2 are what? Numerical values, and U1 and U2 are their units, right? So if I ask you that N1 was what? Numerical value in MK system, if I ask you, so that is basically 6.67 into 10 to the power minus 11. Now units, so if I ask you with the dimensions, if you want to answer, so unit will be basically the dimensions of mass, basically gravitational constant, so mass will be basically represented in what? Kg. So we'll have m in kg, then L, so L is basically in meter, and time is in basically in second, right? So first we'll write in this way, that is MK system, and we have to basically find its value in CGS system, so that is N2. Now mass will be in what? Mass will be in gram, right? Then length will be what? In centimeter, right? And if I ask you about the time, so that will be in your second. Clear? Now basically if we see the dimensions, so what are the dimensions we have seen? M minus 1 L cube T minus 2. So basically what we are supposed to do, we are supposed to write the powers over here, that is m minus 1 L cube T minus 2. Same over here, that is m minus 1 L cube and T minus 2. Now simply you have to find the value of N2 from here. So basically N2 will be what? So N2 will be 6.67 into 10 to the power minus of 11, right? Now this will be in division of this, so we'll have mass in kg upon mass in what? Grams, raised to the power what? It will be minus 1, right? Then we have length, so length in meters upon length in centimeters, and raised to the power what? Cube, and time in second upon time in second, and it will be raised to the power what? Minus of 2. Now basically to find the value in CGS, we have to basically convert kg into G, and meter into centimeter, and second is, time is everywhere in the second. So what happens? Kg can be written as what? See, this will be as it is, so we'll have 6.67 into 10 to the power what? Minus of 11. Now mass is in kg, we have to convert in grams, so basically we have to take 1000 and then mass in grams, right? Divided by what? Mass in grams, raised to the power what? Minus of 1. Then we have to convert length. which is in meter, we have to convert it in centimeter. So we'll have length, that is in centimeter, divided by, so basically you have to multiply it by 100, right? Because we have to convert this into centimeter. So we'll write this as 100 times length in centimeter, because 1 meter is equal to how many centimeter? 100 centimeter. So 100 and then length in centimeter divided by length in centimeter raised to the power 3, and time is same, so we'll have time in second divided by time in second raised to the power what? Minus of 2. Now m of g will cancel out, L of centimeter will cancel out, and T of second will cancel out. So what remains is your 6.67 into 10 to the power minus of 11. Now from here we'll have 1000 to the power minus 1. 1000 can be written as 10 to the power 3 and minus 1. So this is basically your 10 to the power minus of 3, right? And if you see this, so you have 100 to the power 3. 100 is 10 to the power 2 and 2 to the power 3. So that going to become 10 to the power 6. Now you solve this further. So you'll have 10 to the power minus 14 and 10 to the power 6. So in all, you'll have net 10 to the power minus of 8. So you'll have the final answer as 6.67 into 10 to the power minus of 8. Now that's going to be its value in the CGS system, right? Now you have to write the unit as well. So for unit, what basically we are going to use, we are going to use the same formula, that is G m1 m2 by r square, right? So basically force will be in the CGS system. You must be knowing that the force in the CGS system is represented by dyne, right? So basically 1 Newton is equals to 10 to the power 5 dyne. So we'll use over here dyne, unit will be dyne. Now the distance is in centimeters, so this will be centimeter square, right? And per of gram square, because mass will be, in this case it will be gram. So that's the value in the CGS system, and that is going to be its unit. I hope you understood. Let's move further. So we have deducing a relation among the physical quantities. This is another important applications of dimension analysis, because जब भी हम dimension analysis की बात करते हैं, so basically वहाँ पे हमें एक relation deduce करना है among some physical quantities. We have certain quantities और हमें उसमें एक relation establish करना है. So how we'll do that? Let's understand it. Fine. So that is basically we have to find a relation among different factors by using principle of homogeneity. What do you mean by principle of homogeneity? I have told you multiple times that principle of homogeneity means you are representing a particular equation, and in which the dimensions in the left hand side is equals to dimension in the right hand side, right? So we'll move further. So we have the question based on this, and through question we'll understand that how to deduce a equation, right? So basically in this question we are given that we have to derive the expression for time period, and that particularly of a simple pendulum, which depends on, so basically what it is given, that time period which is denoted by capital T, and that depends on the length, mass and gravitational acceleration, right? So what we have to do, simply you have to take time period, proportional sign, then length is represented by what? L, raised to the power will take A, because we don't know that whether it is a square or cube or simply a 1. So that's why we are taking L to the power A. Then we have M to the power what? B. And then we have G to the power C. Now this M is mass and G is acceleration due to gravity. Now using the dimensions, we have to basically establish a relation between time period L and M and G. So what we are going to do, we are going to use the dimensions. So what are the dimensions of time? So basically that is going to be M0, L0, T1. I hope it is clear that dimensions of time period is M0, L0, T1. Now when we'll remove the proportionality sign, so there will be a constant called K, right? Now if I ask you the dimensions of L, so what will be the dimensions of L? So you'll have M0, L1, T0 raised to the power what? A. Now for the dimensions of mass, so we have M1, L0, T0 raised to the power what? B. Now we'll use the dimensions of acceleration due to gravity. So we have M0, L1, T minus 2 and raised to the power what? C. Right. So once we write this again by collecting the terms, so in the LHS we have M0, L0, T1, right? equals to k. Now in the RHS we'll collect the terms, so we'll have m to the power what? From here 0 into a is 0, 1 into b is b, and 0 into c is 0. So ultimately m to the power what we have? We have b, right? Then L to the power from here we'll have a, from here we'll have 0, and from here we'll have c. So we'll have L to the power a plus c, because they are in multiplication, and we know that when the bases are same and they are in multiplication, the powers gets added up, right? So we'll have written as L to the power a plus c. Then when I talk about time period, so this is going to be 0, this will be also 0, and from here we'll have minus of 2c, right? Because this is minus of 2 and multiplied by c is going to be minus 2c, and from these two terms we'll have t to the power 0, right? So that's the expression of the right hand side and the left hand side. Now simply we have to just compare the powers. Now when you compare the powers, so you'll have what? B is equals to 0. What does this mean? This means that it does not depends on mass, right? The time period of a simple pendulum does not depends on mass, because anything to the power 0 is 1. So there will be no term of mass, right? So we'll see the powers of L. So we'll have what? A plus c, and that is equals to what? 0. Because right hand side we have the powers of L as what? A plus c, and in the left hand side it is your 0. So you have compared a plus c with 0, right? Then we have the powers of t. So you have minus 2c, and that is equals to 1. So if I ask you the value of c, so that is going to be what? Minus of 1 by 2. Now once you put this value in this equation, so definitely if c is minus half, so minus half will go that side, so we'll have the value of a as what? Plus half. So finally we got the value of a, we got the value of c, we got the value of b. So that was our aim to find out. So basically we can write this expression now further as time period directly proportional to, we have taken time period directly proportional to L to the power a, m to the power b, and g to the power c. So we'll have L to the power 1 by 2, m to the power 0, and g to the power minus of 1 by 2. So basically time period becomes proportional to L to the power 1 by 2 and g to the power 1 by 2. So time period, when we remove the proportionality sign, we have the constant called k. So we have the formula for time period, that is equals to k under root L by g, right? So that's the basically formula for time period. Means now what is the limitation of dimension? If I ask you that dimension की एक बहुत major limitation है कि जो constant है वो हम पता नहीं लगा सकते, that what exactly that constant is. अगर मैं आपको actual expression बताऊं इसका, so basically that expression is time period is equals to 2 pi under root L by g. So जो actual relation है that is this, right? But जो dimensions की अगर हम बात करें, dimension application की बात करें, तो there is one limitation that you cannot find the k using the dimension. You can get the somewhat relation, but you cannot find this constant term, right? So that's the limitation. I hope you understood well. Thank you.